Hi all, this is the lesson on sections 2.5 and 2.6, focusing on income elasticity of demand and price elasticity of supply. Again, we'll be going through the basics here before we go a little bit deeper in class. So, income elasticity of demand is a measure of the responsiveness of demand of a good to a change in income. The equation is similar to that of PED, substituting income for price. Why is income represented by Y and not I? Well, I is already taken in economics by investment, and I guess they figured Y at least rhymes with I, so that's why. Anyway, we just need to accept it. Now, let's say income's increased by 20%. This might have the effect of decreasing demand for Nescafe Blend 43, which is what my frugal parents drank when I was younger, by 10%, might decrease it by 10%. By plugging in the values, we see that YD is negative 0.5, and this shows us that it's an inferior good, but of course, you might have guessed that anyway from our work in the last section. Unlike PED, the sign matters for YD. A negative value indicates an inferior good, for example, regular beef mince. A positive value indicates a normal good, such as a new car. It's important to remember here that these classifications do vary by demographic. So poorer people who get an increase in income will buy more Mazda 3s, whereas those who are already significantly wealthy, they'll buy fewer when they get a higher income. They'll instead shift their demand to a more luxurious car. Here, we also introduce two new classifications of goods. Necessity goods will have income inelastic demand. Demand will be relatively non-responsive to a change in income. If your income doubles, how much more toilet paper are you really going to need? How much more bread? How much more petrol? So you might buy more, but it's not going to be much at all. Then we have luxury goods, which are highly income elastic. So the YD will be greater than 1. A small increase in income can drastically change our demand for things like the overseas holidays or fancy high-end watches. And when our income decreases, these are going to be the first things that we cut out of our consumption. So it's very responsive to a change in income. Next, we'll look at a way to show these classifications on a diagram. This is called the angle curve. We've discussed McDonald's before. Is it inferior or is it normal? That depends on our income. I've put up some basic values here. So let's say you're earning 30 grand a year. Macca's might be a special treat, so a luxury. So as your income doubles from here to 60,000 a year, you might buy a lot more Macca's. You think, wow, I'm doing great. I'm going to treat myself. This is what I'm going to do. Demand is income elastic. So YD is greater than 1. It's very responsive to a change in income. As income doubles, McDonald's consumption more than doubles. So it goes from 10 to 25 per year. Okay, as income continues increasing to 100,000 from 60 up to 100, Macca's doesn't quite seem quite as special anymore. People may still buy more, but it will be less than proportionate increase relative to income. So YD will be positive, but it will probably be less than 1. This puts it in the necessity category, but calling Macca's a necessity is perhaps problematic, but it makes sense if we're thinking about the numerical values and what those values show us about consumption. Now, as income goes up from 100 to 150, we might buy just as much Macca's as we did before when our income was at 100. So as it increases, we might not increase our consumption, we might not decrease it. In this case, YD would be equal to 0. It seemingly has no effect. The change in income has no effect on how much on the quantity demanded, how much you're going to buy. When we start earning the real big bucks from 150 onwards, most would start to buy less Maccas. They would start to turn to better, more expensive food. So this diagram here just adds a bit of nuance to the idea of classifying goods according to YED. It's not always straightforward. Now we will move on to price elasticity of supply. This is a measure of the responsiveness of quantity demanded to a change in price. We're familiar with the law of supply that states that if price increases, quantity supplied increases, but by how much will it increase? And by how much will it decrease if price falls? The equation is similar to that of PD. Remember, you Q before you P. Let's take Christmas trees as an example. One year, due to extra demand, the price increases by 30%. And quantity supplied increases by 2%. Okay, 2 over 30 is 0.07, and we follow the same rules as PED, where a value of less than 1 is inelastic. So why would supply be so unresponsive? Shouldn't the farmers want to sell more if the price increases and make some of that juicy profit? To answer that, we'll examine the determinants of PES. How much do costs rise as quantity supplied increases? If you're running a car factory and the price increases, what would factor into your decision about increasing production? If you're at capacity, you would have to build a new factory. So that would require a significant increase in price to make that huge investment worth it. If you're not at capacity, it's a relatively simple equation. One thing that factories might do is start a night shift. So they make best use of their current capital. So they might work all 24 hours of the day is what I'm talking about there. Now, just like PD, the time period considered matters. Take Glenunga, for example. We have a huge demand for student places, and in the short term, we couldn't increase the number of students we educate. Which is what we supply, I guess, is a number of spots in classes. So we couldn't increase the number of students we educate, even if the price increased significantly. Supply is inelastic. In the long term, we can do things like build new buildings, making our supply more elastic to price. In fact, the state government is responding to inner city demand for high schools by building the new Botanic High School on Frome Road. Now, production time is crucial to PES. Goods with a short production time, like DVDs, can be produced rapidly at the push of a button in response to an increase in price, making them responsive or elastic. Goods with a longer production time can't respond to a price increase in the same way. You can't just grow another ton of apples in a week. There's a long lead-in time. You need to get more land, the trees have to grow, and the apples have to grow. You can see how this is very related to the time period considered. A sustained increase in the price of wool will lead to a greater increase in sheep grazing, and in the long run, supply can respond to the increase in price. The ability to store stocks determines PES as well. Some goods can be stored easily, for example, televisions, and can be released as needed, whereas goods like milk and services like labour need to be provided more on demand, rendering them more inelastic. You can't store up accountants' hours during the year to suddenly release all of their services during peak tax time, and nor can you produce all your milk at once and then keep it and sell it when people want it. You can't just stockpile it because obviously it's going to go bad. Now, lastly, how easy is it to mobilize the factors of production? If a car maker notices a large demand increase for one of their models, much of their machinery and labour is perfectly suitable to switch from the less popular model to the more popular model. They can respond to the increase in demand. But supply might be priced inelastic if there are highly specialized skills or machinery that are used to produce. So if they're non-substitutable, then supply is more likely to be inelastic. So that's YD and PES, and we're going to work on some exercises in class to deepen our understanding of that.